Alright, so here we are now continuing from the last video. In the last video we just had a brief discussion of the concept of the equation of a straight line. Very brief, right? It's something that we could delve into in some more detail later if necessary. Alright, now we're going to get into the mechanics of finding the equation of a straight line. Alright, so suppose we have 2 points on a line segment. Alright, the point A minus 3, 6 and B 5 minus 4. We know from previous work that the gradient of this line, that we call the gradient M, is equal to y2 minus y1 over x2 minus m1. And recall that it doesn't matter which point we use as x1, y1 and which point we use as x2, y2. Alright, so I'm going to leave it to you to go through the mechanics of it on your own to show that the gradient of this line is, let me say if this one is x2, y2, this one is x1, y1, then it will be 6 minus minus 4 over minus 3 minus 5. Or if we use this point as x2, y2 and this point as x1, y1, then the gradient will be minus 4 minus 6 over 5 minus minus 3. Either way, the final gradient will be minus 5 over 4. Alright, so that is an exercise for you. Just what, 2 minutes, 3 minutes maximum. Double check and make sure, prove to yourself that it doesn't matter how we label the 2 points in terms of x1, y1 versus x2, y2. The gradient will be the same so long as the algebra is correct, of course with reference to your signs and so forth. Alright, so now we're going to get on to the other matter of finding the equation. And again, in the same way that it doesn't matter how we label the points with respect to the gradient, we will demonstrate that it doesn't matter which point you use, the equation will be the same. Alright, so before we do the actual calculations, I just want to state that to find the equation of a straight line, all you need is the gradient of the line and one point through which the line passes. Alright? So the necessities for the equation of a line would be the gradient of the line and one point. The point could be this A or this B or any other point that we choose to identify on the line, if we can identify such a point. Right? Of course, it makes a lot more sense to use the points that you already have. Alright? Now, we know the formula for the equation of a line. We would have seen it before. What I'm going to do here is derive the formula so that you understand exactly where the formula comes from. The intention being that you will remember it better, and if for any reason you blank out on the exam itself, you could go through the steps to derive the equation of a straight line, right? Of course, the idea will be that you do so many questions to practice that there's no question at all of blacking out on the exam day itself. Alright, so what we're going to do is consider a general point. We call this general point now x, comma, y. Right? As a general point on this line segment AB. Right? X is the x coordinate, y is the y coordinate. We don't know what the x coordinate is or what the y coordinate is. Right? So how would that play into us finding the equation of the straight line? Well, we know that the gradient is minus 5 over 4. Right? So all we're going to say is look at this general point with respect to A, or look at this general point with respect to B. Either way, we're going to get the same equation of the line. So basically all we're doing is finding the gradient of the line with reference to 2 points. One point being a general point xy, and the other point either being A or B. Alright? So consider the fact that the gradient of this line is y minus 6 over x minus minus 3. the gradient of this line is also y minus minus 4 over x minus 5. Anyhow we look at it, same gradient, so you'll get the same equation. And I will demonstrate that to show you now that it doesn't really matter which point you use, as long as you have the gradient and one of the points, you could find the equation of any line. So, you could say now, we know the gradient formula, so we could say that y minus 6 over x minus 3, right, is equal to the gradient minus 5 over 4. And then in this case now, we just cross multiply. So the next line here would be that y minus 6 is equal to, so I make some space here. The next line would be that, y minus 6 is equal to minus 5 over 4 into x minus 3, right? So what I will do, I will send a document attached to this video where I'm going to finish the calculations, right? So I'm not going to waste too much time trying to make space on the board because we don't have time for them kind of things now, alright? So the video is just explain and you will see the calculations in the document, alright? By the same token, if I choose this general point and this other point, it will be 5 minus 4. Right? In that case, the gradient will be, I'm coming in the corner here now, right? The gradient will be that y minus 4 over x minus 5 is equal to the same minus 5 over 4. Which is to say then that y plus 4 is equal to minus 5 over 4 into x minus 5. Alright? So, just as we did here, the document attached to this video will have the completion of the calculations here. So, in other words, we don't have to spend more time making these videos than we have to. Alright? Because there's a lot of work to make these videos and there's a lot of time. But that's alright. That's not the issue, right? We're trying to be efficient here. We're trying to make use of all the resources that we have at our disposal, right? Because of the recent disruptions in terms of classroom, class attendance, etc., etc. Alright? We still have a job to do and let us get it done. Alright? So, I will work one more example in the video and I will attach the write-up for that as well, and then I'll leave you with questions to practice. So in this case, what I'm going to do is give you two random points. But the points not as random because I actually use these 2 points in one of my face-to-face sessions, right? The points are A32 and B78. So suppose you're in an exam and you get a question like that. No diagram, all they give is the 2 points and then they ask you to find the equation of the line joining these 2 points. Alright? So you have the point A32, which you could label as 1 point, and you have the point B78, which you could label as another point. Alright? So for those of us who are diagrammatically inclined, it doesn't matter how you orient the line. As long as you show that 2 points are connected and you label the 2 points, then you have absolutely no problem. Right? So, and again, I always like to encourage people to draw diagrams wherever possible when they're doing these questions. It helps, it goes a long way, it makes a big difference. Alright, so you have your 2 points. Let us, for the sake of consistency, label both of them. Alright, at the same level. 3, 2, and this is B 7, 8. Alright, good. And we want to find the equation of this line segment. Well, the first thing we need to do is find the gradient. We can't have an equation without the gradient. Alright, so we find the gradient. And again, it doesn't matter how we label the points, x1, y1, x2, y2. Let us call this one x1, y1. Let us call this one x2, y2. Alright? So the gradient will be y2 minus y1. Right? Y coordinate minus y coordinate, 8 minus 2 over x2 minus x1. So 8 minus 2 is 6, 7 minus 3 is 4. So the gradient there is 6 over 4, which is 3 over 2. Alright? Now, do not try that mentally in an exam, right? It is your responsibility as somebody doing the exam looking to get marks to write out all the steps. I am just calling it out mentally in the interest of the whole video thing here. Brevity, etc., etc. Alright? Yes, brevity is a word. Go and check it out for those of you who do it English. B-R-E-V-I-T-Y. Alright? So we continue. So the gradient is 6 over 4, which is 3 over 2. So write on the gradient. The gradient M is equal to 3 over 2. So, having found the gradient, we are now in a position to find the equation of the line using any one of those 2 points, and we could confidently expect to get the same equation, because that is just the nature of the mathematics. Right? So even though we start with slightly different figures, the equation will work out to be the same in the end. So let us work one side. Alright? So we can say then that, again, we consider our general point xy, right? Then we call this p xy. Alright? So the gradient of this line between A and P will be the same gradient between P and B, else it wouldn't be the same line. Alright? So that is why we could use any of the 2 points and the gradient to find the equation and expect to get the same equation, because even though the 2 points are different, they lie on the same line. Alright? So, watch it now. We say that y minus 2 over x minus 3 is equal to 3 over 2. And this time I'll write it out because we have a little more space to use. Alright? So the next line would be y minus 2 is equal to 3 over 2 into x minus 3. And then we continue the calculations. Right? Y minus 2 is equal to 3 over 2x. 3 over 2 by 3 is minus 9 over 2. Right? So y is equal to 3 over 2x minus 9 over 2 plus 2 is the same as 4 over 2. So y is equal to 3 over 2x minus 5 over 2. Alright? So this is what we get when we use the point A, 3, 2. Right? Y is equal to 3 over 2x minus 5 over 2. So look now as we get the same equation using x, y, and 7, 8. Alright. So we have here now that y minus 8 over x minus 7 is equal to 3 over 2. Right? So y minus 8 is equal to 3 over 2 into x minus 7. And we come again now and we say y minus 8 is equal to 3 over 2x minus 3 by 7 is 21 over 2. Alright? So y is equal to 3 over 2x minus 21 over 2 plus 16 over 2. 8 is 16 over 2. So therefore y is equal to 3 over 2x minus 5 over 2. Alright? This is minus 21 over 2 here. So we have the same equation. Y is equal to 3 over 2x minus 5 over 2. Alright? So the reason why I did it like this, starting off with the gradient, is because I try to minimize the need to remember the formula. Yes, the formula sheet that I gave you have y minus y1 is equal to m into x minus x1, which is the same thing. Right? Watch it. Alright? The same thing. So that is what we have there, right? So get all that off now. So just to discuss the general equation, right? We know from millions of textbooks and from the sheet that I give you that y minus y1 is equal to m into x minus x1. Now if you remember that, then fine, absolutely fine, totally perfect, right? If however you don't remember it, all you have to do is understand that you have a general point pxy, and let us say you have another general point q, x1, y1, alright? We know then that the gradient between these 2 points is, watch it, y minus y1 over x minus x1, which will be equal to the gradient. And then if we cross multiply, the next line will be that y minus y1 is equal to m into x minus x1. So that is how we get the formula for the straight line. Alright? So we went through the procedure here. Just remember that the equation is derived from the gradient. And the gradient is derived from any 2 points. We can have one general point and another known point. Alright? Of course, the general formula being derived from 2 general points. So all we do is we consider the general point xy and we make one of these 2 points to be the x1, y1. Alright? So all we really need is the gradient and 1 point. So in this general equation here, we need to have this and we need to have x1, y1. Once we have that, then it's just a matter of substituting the values in this equation or in this equation, and we will get the equation of a straight line, right? Which we could express in the form y is equal to mx plus c, or we could express it in the form ax plus by plus c is equal to 0, which I will discuss very briefly in the next video. Alright, so that's basically it. The next step, of course, is to work questions so that when they bring that question on the exam paper, you don't have a problem to find the equation of a straight line.